We have put together a panel of leaders today that will be talking about some of the trade-offs and sort of nuanced decisions that engineering leaders need to think about as they are entrusted with actually delivering on those multi-cloud strategies as they take shape. So please join me in welcoming our panelists today. We have Joe Duffy, who is co-founder and CEO of Pulumi, a multi-cloud infrastructure as a code platform. Justin Fitzhugh, VP of Engineering at Snowflake, who leads cloud engineering and Snowflake's multi-cloud strategy. Thank you, Justin. And handing the mic back over to David Carter of the Sapphire Ventures fame. Take it away.
Thanks, Shruti. So, guys, Justin, thank you both for coming on today. Look, I think we're super excited to be hosting this panel with you both. It's a topic that I think is near and dear to a lot of people's hearts. I think a lot of the companies that are in the room today probably have some version of sort of a multi-cloud or hybrid cloud strategy that they're embarking on, and if they're not, they're at least sort of having the conversation. And I think one of the things that's super interesting that we always love to hear about just in talking to people about their strategy is some of the motivations, and we hear sort of wildly different things about sort of like the why behind people doing this. So, sometimes it's go-to-market focus, sometimes it's like, I have this big customer and they're competitive with Amazon, whatever it is, but it's always intriguing to hear some of the rationale. So, Justin, maybe that's a good place to start with you. Just, would love to learn a little bit more about kind of the why behind Snowflake's multi-cloud strategy, and some of the benefits that, that are probably sort of aligned with the rationale there.
Sure, yeah, it's interesting because that's the first place I start generally when people talk about multi-cloud is the why. And I get very strange answers sometimes of, because of competitive pressure or because I was told I should or something. And I think that it's really important to really understand the why. And for Snowflake specifically, it's around having choice amongst various cloud providers and being able to be agnostic to those cloud providers. But I've seen a lot of other businesses, sometimes people go down this path and it's not actually to their benefit. And so I think you really need to look at it from a balanced approach of what is the business objective first, and then what tools or what clouds or why are you looking at multi-cloud to accomplish that, as opposed to, I think I should be and I'm gonna go do it. And often that'll cause lots of kind of negative consequences, I think, which that don't necessarily accomplish the business goals. So for Snowflake, it's one of our kind of founding principles and something that's kind of core to our business and how we differentiate, how it's competitive. But I think in other industries and other companies, that's not necessarily the case. And so it should be looked at carefully in terms of how is it a tool meant to achieve your business goals as opposed to something I should do because I've heard of it or something like that. So I don't know.
Yeah, so Pulumi, we help customers, with all different clouds, Google Cloud, AWS, Azure, on-prem workloads. And so we kind of see it from many different angles. I would kind of summarize multi-cloud. What we see with our customers is three categories: business, product, and technology. I think business is, for example, we just helped the largest retailer in Latin America move off of AWS for obvious reasons, because Amazon is now starting to move more into Latin America. So that's a good business reason. Whether that's a good one or not, it's sort of paranoia, but it happens. There's also, price negotiation power. One of our customers is top 10 customer of AWS and top 10 customer of Google Cloud. And that means they can, walk into Google, put their Amazon mug on the table and demand a discount and be pretty successful at doing that. I think the product, it's similar to Snowflake, right? Snowflake wants to meet customers where they are and they're probably in AWS and Google Cloud and Azure. And if you only pick one of them, you severely curtail your TAM. And that also happens, a lot of SaaS companies get dragged kicking and screaming into on-prem once you start going into large enterprises. And so being able to have that flexibility of running anywhere is beneficial. And then technology, each of the clouds has different capabilities. Cosmos DB in Azure is very different than Redshift in AWS, which is very different than Spanner in Google Cloud. And if you're doing AI and ML workloads, that's even more different. That said, there is sort of a layer of commodity emerging. The existence proof of that is Kubernetes, right? Some amount of the compute is pretty standardized across the cloud providers, but each one of them has something that makes them special, and you might want to tap into those technological differences.
But the only thing I'd add to that, which I totally agree with, is don't underestimate the cost of being a multi-cloud. And we'll get into some of these questions a little bit later, but there is a price you pay, a tax you pay to stay in a multi-cloud environment. And my point earlier was just that make sure there's a valid business reason that justifies that cost and why you're doing it, because for some cases it makes all kinds of sense, and there are many businesses where it may not make sense. It depends on that. And so I think that a lot of times people go into this multi-cloud journey saying, hey, it sounds great, we should do it, it's something that I think is right, but there is a significant cost, which I personally can tell you how much we carry and how much burden kind of follows with that. So it's not to be taken without understanding that cost and understanding that impact, I would say. And if it matches your business goals, fantastic, but if it doesn't, then I would evaluate it.
Yeah, just one last point, I'll kick it back to David, is to build on that, is there's this sort of another reason, which is premature lock-in avoidance, which we hear all the time, especially from large enterprises. I was actually just meeting with a Fortune 50 CIO a couple weeks ago, and they were like, hey, we wanted to go to the cloud. So step one, of course, was to build this like abstraction layer that abstracts over every single cloud provider. And guess what? 3 years in, they're declaring that it's a failure and deciding, okay, we're actually gonna just go native to AWS. And so you do have to be careful.
Yep.
It is expensive.
Yep.
Super interesting. Joe, I actually just wanted to pull on one of the comments that you made just about sort of what you're seeing from various customers out there and how people are approaching this. And I think, oftentimes we just sort of assume when we hear the word multi-cloud, like everyone has sort of a vision of what that means, right? Like you're running across these different providers, but what are some of the common sort of architectural patterns that you're seeing that are prevalent out in the community? I mean, are people sort of like just cut and pasting the same application and run it across all three? Is there, is it common to run sort of like particular workloads, like, train models on Google and then like run your web front end on Azure? Like, how do you think about sort of the different ways that people are sort of approaching this?
Well, I think first there's this amazing new technology and company called Pulumi that's helping people do this. But anyway, it's not a commercial. I think there's sort of two interesting dimensions. I think there's like the workflow and processes, like how does the team operate? How do you ensure that you're provisioning the workloads? How do you secure them? How do you have visibility into cost and controls? And then there's the actual workloads themselves. Like, can you actually run this application on any cloud? And is it agnostic? Is it 80% agnostic? And then you specialize for each cloud target? So I think they're very different. I think the workflow, that's where we come in. It's similar to like a HashiCorp or even VMware for some slightly different kind of workloads. The ability to standardize your processes and the way your team works and how you deliver your software and how you secure it, independent of the cloud provider, I think that is goodness pretty much no matter what. Because you can put in place timeless practices that are going to scale as your business scales and insulate you from future decisions you might make. You might decide, hey, we're going to go to Google Cloud. In many cases, actually, the cloud providers, actually, Justin kind of makes this point sometimes around platform engineering. Like, to take the capabilities of one cloud provider and then make it work in a team, you actually have to build a platform around it. And there are companies like Pulumi and HashiCorp that are helping to build those platforms for you, or at least pieces of them. The workloads being agnostic, that's a very tricky story. And a lot of people bet on Kubernetes for that, for example, but that only gets you 80% of the way there. There's still data services and other services that are specific to each cloud provider. And so I think there's sort of a false belief that Kubernetes is a panacea and you just sprinkle a little Kubernetes on it and you automatically get multi-cloud. It's a lot more difficult than that.
Maybe, so to that end, Justin, and I think you touched on this a little bit earlier, but just can you talk through some of the challenges and some of the sort of thing, like the key considerations as you make this jump? I think of things like asset visibility and, Joe brought up provisioning, and there's this sort of scenario where maybe you wind up with the lowest common denominator of services. So curious what you think are sort of like, should be sort of top of mind from a challenges perspective that people need to think about that are, going from one into maybe their second cloud and they're just getting started.
Yeah, so Snowflake actually started in Amazon first, was originally only at Amazon. We went to Azure and then we went to GCP, and we did this. Each step of that we did there was I would say, 20 to 30 engineers for a year to 2 years, maybe more. So the porting exercise is actually fairly significant. And that's because we were in the exact same software, the exact same feature set across all 3 clouds in the same way, so the customer has the same experience. That's like the extreme of multi-cloud. I think there's lots of different types of multi-cloud that you can look at, kind of to Joe's point around having kind of taking the advantages of each of the clouds. But so for Snowflake, I mean, as we went down that path, we started Amazon, we still had this mindset. The core concept of Snowflake is disaggregating compute from storage, right? So at the same time, we also wanted to think about disaggregating from native cloud service providers so we could look at different CSPs and give customers choice and flexibility across clouds. But when you start in Amazon, you think we thought about it, and then going to Azure obviously was next. But there's so many different concepts around VM types, around authentication architectures, around even the way you think about subscriptions versus accounts, how you think about IAM policies, how does that translate? How do you think about storage performance? Or Snowflake happens to be obviously very I/O sensitive, and so you look at a direct attached disk versus an object store and how the performances are different. There's a lot of variety, and so what I think what we did, and I did this actually fairly early when I got to Snowflake, is I established kind of a document that said these are the core services that we must have to run Snowflake, and this is the parameters that we need to operate and run Snowflake. And we spent a bunch of time kind of really hammering those out, months, and making sure that it was fairly accurate. And then when we go look at a new platform or a new provider, or we go back to a provider, we have a really clear idea of kind of what those kind of core building blocks are. And that's been really, really helpful. So I would encourage anybody, if you haven't done that already and you're on a CSP, at least understand what services you're dependent on and what you're using, because that gives you a roadmap to, like, how would I, if I wanted to go to multi-cloud, at least I kind of understand my inventory, understand where I'm going, and can kind of understand that cost. And so we did that as we went to Azure, and then when we went into GCP, again, totally different model if you look at project-based and kind of how they do things. Same kind of fundamental concepts, but they're not going to make it easy. I mean, there's a reason why Pulumi and Terraform and these types of tools exist, trying to abstract that away, which is difficult to do. I will say I think containerization is super helpful. When Snowflake started, there were no containers. It's all VM based, and we have our own orchestration system and such. But I would say that's an area that we continue to look at, is how do we containerize to abstract from the operating system as well from the cloud. It gives you some level of abstraction, but to Joe's point, Kate's or containerization, whatever you want to call it, is not going to be sufficient to be like, oh, great, you just pick your application up and drop it on another cloud. There's so many more facets, and understanding how do you translate those things together. So I would say, start with that inventory, start with what you have, really deeply understand what, and be deliberate about any dependencies you're taking on those cloud providers. So if you're going to take a dependency specifically, say on key management and using KMS or something from Amazon, for example, understand what you're doing, what that would imply if you needed to abstract that, because I think a lot of times people go down this path of get to market very fast on one CSP, take everything they have and move quickly. But then you're like, oh, what do I do when I have to? So just understand that and make sure you're making explicit choices when you do that. And it could be the right answer to continue to go down and leverage those services. I think in 60, 70% of the time in businesses, I think it's actually better that people start or focus on a single CSP because they get to market faster, because the benefit to being multi-cloud may or may not be there. Maybe that changes over time, but you want to be explicit about that choice and the choices you're making there, as opposed to letting them happen and then figuring them out kind of later on, because that's much more difficult to solve.
So I think that's super interesting. That's actually another question that I wanted to ask, which is just around the trade-offs between kind of the native services and third-party services. I think, Joe, you touched on kind of lock-in avoidance, and maybe that's a reason to go with third parties. But then there's other trade-offs where there's maybe just more sort of elegant and tightly integrated capabilities by leveraging what's there and sort of like what's provided out of the box. So curious, I guess, question is for both of you, just how you think about how people should think about approaching that, and sort of what is the cost longer term if you kind of go too far down the path and then have to kind of pull back?
I think it really, really depends on your scenario. I think in most cases, I think Snowflake's kind of an extreme example where multi-cloud is a requirement, right? Multi-cloud isn't always an intrinsic business requirement. And I think for many people, like if you're an early stage startup and you're building on AWS and there's a service there that's going to save you a ton of money or save you a ton of time, like you kind of be ridiculous not to use that, right? But I think even at scale, even when you get to multi-cloud, you can take advantage of some of the unique capabilities, the things that make the clouds special. Some analogies I often use kind of terrible analogies. I find them useful. Like if you're building a game engine like Unity, and you want that to run on Android and iOS and Windows. Like 80% of Unity is probably common to all of those platforms, but 20% you're going to specialize for the interface with the graphics subsystem, et cetera. Same thing, I worked at Microsoft for a long time, and the Office team, right? Yes, they had Android and iOS and Windows teams, but the specialization was a subset. They wanted to keep as much common as possible, and I kind of think about that in the cloud. It's like, what is the 80% that can be common, and then what's the 20% that either has to be unique, because let me tell you, IAM on AWS is super different than security and Active Directory everywhere on Azure, for example. But then there are places where you might want to take advantage because of extreme cost savings, or it's just a better experience, right? You might have a feature that just is better on AWS, and that's fine if it provides business value. So I don't think there's one cookie cutter answer, but to me, if you're erring on the side of taking advantage of what makes the cloud special, that's probably the better side of the coin to be on.
Yeah, the 80-20 rule is a good one. Even with Snowflake, for example, we do some functionless stuff for automated account setup and such. We only do that in AWS and only in Lambda because we think it's better. It doesn't. Why would I port that to 3 clouds? There's no advantage to me there. Or say DNS services, for example, trying to run DNS across 3 cloud providers and have it seamlessly fail, that's almost impossible problem. And so we leverage Route 53 in that case. So there are cases where I think you take best of breed and you focus that, but I think you also look at how do you implement such that if you wanted to change or you needed to swap that component out, you could. I think where you have to be really careful is if you take advantage of a unique service to a cloud, because now you've tied your horse to that wagon, and it's going to be very difficult to unwind. So if there's when we look at these dependencies we take, we either look at what happens if it completely went away, that's fine, or if we had to swap that component out. I think that's another case that makes sense to look at kind of cloud specific services.
Maybe just one other one on tools, and Joe, maybe this is a softball for you a little bit, but just we've talked about IAC frameworks and sort of the value, but what are some other kind of capabilities that you guys are seeing that are just like absolutely fundamental that people are sort of naturally gravitating towards third parties to help them with sort of this multi-cloud strategy and multi-cloud kind of development? Just curious, and I know Justin, you and I have spoken about kind of this orchestration layer that sits above these pieces. So just curious how you think about that.
Yeah, so I mean, I'll start and I'll softball it over to you for Pulumi. But I think that there's all these ways to manage infrastructure. You have the cloud service provider APIs. You have Pulumi. You have Terraform. You may have Chef or Ansible running around. You may have all kinds of different common pieces to manage this infrastructure. What we found was missing is what ties that all together in terms of an overarching business process. What says, okay, I want to build a Snowflake deployment. Now it's going to kick off something that generates a certificate, say, in Digicert, brings it back, kicks off some Pulumi code to go build X, understands to work with the CSP on how to kick off a K8s cluster if we need that, or VMs or something like that, and then kind of has manual, maybe some Slack approvals that have to go through there. What's tying that all piece together? Because what we had is this extremely long list of like 80 things that was on a wiki page that somebody sat there and typed out, and was anytime you have a human, you're going to have errors, and you can't actually test that on a, say, nightly basis to ensure it continues to work. And so for us, that was the missing link that we needed, which is this overarching orchestration system. And so that, I think, is an area that's still kind of growing and expanding, and I think is an area that is going to continue to become something that's really needed. I think it's somewhat at scale. When you get to scale, you start to see this more than maybe when you're kind of first starting out, but that orchestration piece is one that I'm super interested in.
Yeah, I think the world is very different now than it was 10, 15 years ago. Like, all software touches the cloud in one manner or another. So we've started calling this cloud engineering, which is developers increasingly getting hands-on with the cloud because they want to really tap into distributed application architectures that are uniquely enabled by the cloud. And then also the infrastructure team, who is dealing with, frankly, insane complexity with all these moving pieces. I don't know how many environments Snowflake has, but like many people have thousands of environments worldwide that they have to stay on top of between dev, test, production, multi-region. And so at that scale, really applying more of a software engineering mindset really helps to break down the barriers so that software engineers can be hands-on with the cloud and infrastructure teams can actually tame the complexity of the cloud. But that requires you to really have much more of a unified sort of SDLC where you're actually doing code reviews for your infrastructure. You're actually doing continuous delivery of infrastructure and applications. It's not one or the other. You're continuously verifying it with tests and policy enforcement. And I think everything we've done with software engineering over many decades now actually does apply to infrastructure as well. I think the workflow is kind of, frankly, an unsolved problem because infrastructure workflows are slightly different than application workflows. You do have cost approval. You do have humans potentially in the loop who have to approve something over Slack, or workflows can span days or weeks. Look at how AWS does deployments. Many of their deployments take a month to roll out worldwide with canaries and automatic rollbacks, and that's one of the more sophisticated systems in the world, as far as I know, for how to do this. A lot of people have to build their own, but the building blocks are there. And so Pulumi, that's kind of the space that we're targeting, but there are a lot of great building blocks out, between open source and CNCF, and so that it's not a solved problem though.
So I think we have maybe 20 seconds. I just wanted to, Justin, cue you up for just to pile on to Joe's comment about sort of adopting software engineering principles in particular. And
Yep.
I know we had discussed, and I think you have a pretty interesting journey there just in terms of sort of how Snowflake manages that.
Yeah, I think that one of the key principles that we've had is shifting. When I started there, it was more of an SRE operations org, and we made a deliberate shift to say we're a cloud engineering team, we're hiring software engineers, we're hiring SWEs with an infrastructure focus as opposed to SREs or operations people. And that went well. I would say we swung the pendulum real hard over that way. And now we're actually swinging it back a little bit, which is to kind of acknowledge also some of the operational needs. So we're kind of about 80% SWE, about 20% more traditional SRE DevOps types engineers. And so the only advice I would give, and this is through our own, I don't know about errors, but our own experiences, is kind of as you look at that, definitely having a software engineering mentality of we're building a platform to manage our infrastructure. We're building software to manage our infrastructure as opposed to hiring people to manage it. That's absolutely key. But as you do that, there's going to continue to be an operational excellence, a piece of operational needs that are there, and you have to bring that along. And you have to make that as important as the software engineering side because it will very quickly get thought of as the secondary or not kind of the primary focus. And so we really now have shifted that back a bit to say, hey, we have multiple ladders. We're acknowledging them kind of as equal kind of disciplines within the organization. And it's starting to help, but it's definitely kind of a shift, and I think it's an acknowledgement that you have both, but definitely we tend to trend towards the software engineering side.
Awesome. So thank you guys. This was great. We're a little bit over, so we're gonna have to wrap there. I think we have about 2-3 minutes, keep me honest, where we're gonna clear some plates, and then we'll have our next speaker up. But thank you both.
Thank you.
Thank you.
Yeah. Thanks.